So we've seen how we can use a limit to find values of slope. And what we can do is then we can say, well, if we can find values of slope for different points, we can actually plot all these points and see what happens and see if it comes up with a pattern. So this is what we're going to do here. So this red dot's going to plot the slope values of that purple line. So that slope value there, it looks like it's just a little bit more than 1, so it's plotting a point at y equals 1. And as I move that, if I move that point, as I move that point along, okay, it's tracing out values of slope, and it looks like the values of slope are giving us a pattern. So notice that, yeah, so there's slope of 0, so notice that it's going to give us a dot at 0. Okay, so right up here, at the very top here, again, notice that my slope value is 0 right at the top. I can't quite get that. Okay, so it's definitely tracing out some sort of pattern here as I move that point around. The y coordinates are being plotted in red, and I'm getting different slope values. And as I plot this out, I'm getting a pattern. So this is suggesting that this is in fact a function. Okay, remember that little corner there? That's a bit of a problem there. That little corner, there's a jump, right? From positive slope, it jumps to negative slope, right? And you get a gap in our slope graph. But other than that one little point there, it looks like it's giving us a function, okay? And so what do we need to do? Well, this suggests that the slope values of themselves are a function. So the question then asks is, how can we get the general function that describes this slope? So that's what we're going to do next. We're going to look for this general function that describes this slope.